doctors and fellow friends. Today we are here to present our assignment 2, which is the electric breakdown strength of vegetable oils and mineral oils. Let us introduce ourselves first. My name is Lim Chin Sing.
I am Prasanth Krishnan.
I'm Tien Wee. I'm Shaun. And I'm James.
So I will go through the introduction part first. In recent years, the power demand have increasing rapid growing. So the demand on transformer and insulating oil also increase. So conventional transformer oils is using mineral oils, which is non-renewable and non-biodegradable. This makes a chance for the vegetable oils to become the alternative way to become the insulating oil of transformers. Basically, this vegetable oil is actually extract from the plant seed, something as sunflower oil, palm oil, linseed oil, rapeseed oil, and soybean oils. So in our assignment, we need to compare the breakdown strength of these two types of oil. That's why, firstly, we need to compare their physical chemical properties, which include density, viscosity, second number, pour point, oxidation stability, oil acidity, and fire and flash points. So this table has summarized the comparisons between the two oils. First, the properties is the density. The higher the density, you will have higher dielectric strength and also lower dielectric loss tangent angles. That's why vegetable oils has higher density than mineral oils. In this aspect, vegetable oils is better. Then the viscosity. Viscosity will influence the heat transfer ability of the oils. The higher the viscosity, the lower the breakdown strength of the oil. So in 40 degrees Celsius, the mineral oils has lower breakdown strength than vegetable oils, but at the higher operating temperatures like 100 degrees Celsius, there's not much difference between the two oils, so it's equals. Then the certain number will determine the ability of the oil to ignite at certain temperatures. It means the flammabilities. So with a lower certain number, we will have a low chance to be ignite. That's why vegetable oils with lower certain number is better than mineral oils. And then the pour point. Pour point means the ability of the transformer oil to cold start or operating at lower temperatures. It means the more lower the temperatures, the better. In this case, mineral oil is better than the vegetable oils. And then is the oxidation stabilities. Oxidation stabilities means that the oil is stable or not, or very reactions to the oxygens. If the oxidations occurs, they will release the sludge and increase the oil acidities. This is not good for the oil itself. In this case, conventional mineral oil is still better than vegetable oils. So vegetable oils must go through some treatment before they can apply in the service. Then is the oil acidity. Oil acidity is the same. Higher acidity, they will corrode the transformer. These are not good properties. So in this case, mineral oil is still better than vegetable oils. And then last one is the fire and flash point. These properties is some sort related to the certain number, which determines the flammabilities of the insulating oils. The higher is the better for the flash point. So in this case, vegetable oils has a better one, which are related to this certain number. You see, in both aspects, vegetable oils is better than mineral oils. And I think this is all the comparisons. Then I will pass to my friends.
Okay, thank you, Lim. So now I would like to explain about the pressure of the gas bubble, how the gas bubble influence the insulating oil. Okay. Practically, all of the insulating oil used in the breakdown test is not chemically pure, and the formation of the gas bubble normally is occurred during the process of manufacturing, transportation, and other action, and also according to the bubble and cavitation theory, the irregularity of electrode surface, gas pocket at the electrode surface, or the coronal discharge also will cause the formation of the gas bubble. This, apart from the cavitation theory, thermal breakdown also mentioned that high density current will give rise to the localized heating and lead to the formation of vapor bubbles. According to the cavitation bubble theory, once a bubble is formed, it will elongate between the electrode under the influence of the electrostatic force. During the elongation, the volume of gas bubble remain constant, and the breakdown will occur when the bubble elongate to bridge between the gap. As a result, the breakdown occurs. In other words to say, the background strength of the insulating oil is reduced due to the presence of the gas bubble. Now let us see about some experimental results to compare the presence of gas bubble and absence of gas bubble. Okay, now you can see from here, without the gas bubble, they have an average threshold voltage, higher threshold voltage compared to the transformer with air bubble. Then we see the next experimental result. Here, from this table, it will compare the dissolved gases in the mineral oil and vegetable oil under the typical electrical and thermal force. During the experiment, it will produce the carbon monoxide and carbon dioxide, and the carbon monoxide and carbon dioxide will lead to the acidity, and as a result lead to the formation of gas bubble. Therefore, the formation of carbon monoxide and carbon dioxide will indicate the amount of gas bubble in the insulating oil. From here, we can notice that the camellia oil, which is one of the type of the vegetable oil, produce the largest amount of the carbon monoxide and carbon dioxide compared to the other two types, which is FR3 oil and mineral oil. From here, we can say that the mineral oil has produced less amount of gas bubble during thermal fog testing and typical electrical testing. The reason to cause the vegetable oil to produce more carbon monoxide and more carbon dioxide during the testing is due to the generation of C2H6 and hydrogen gas during overheating. However, for the mineral oil, it produces only C2H4. Therefore, mineral oil will produce less amount of dissolved gas, and therefore lead to the less amount of formation of gas bubble. In this case, it is supposed that mineral oil is more stable than vegetable oil, since it produces less acidity and gas bubble under high temperature and agriculture. Okay, that's all for me. Thank you.
Okay, so I'm going to talk on my part, which is reduction of dielectric breakdown voltage in vegetable or mineral oil due to moisture content. So how does moisture content affects the breakdown voltage? As you can see, the heat transfer medium, moisture, the oil, the transformer oil or vegetable oil used will be the heat transfer medium and as a dielectric material. And then the breakdown voltage study will be directly proportional to moisture content. So we know that vegetables oil are biodegradable. So in my studies, what I found in my reference, this was on PFAE, which was a palm fatty acid ester oil. And then we know that from my finding, I got to know that vegetable oil absorbs more moisture than mineral oil due to its high concentration of unsaturated fatty acids. And the vegetable oil becomes unstable and prone to oxidation. So it is mainly composed of triglycerols, which is glycerols esterified by 3 fatty acids. And then fatty acid carbon chains and their concentration of unsaturation influence the dielectric strength of the oil. So hygroscopic and hydrophilic at atmospheric temperature. So what does it mean by hygroscopic? This hygroscopic means tendency to attract water or moisture from air. And hydrophilic means tendency of mixing moisture in the oil. And then water molecule is polar in nature. Oxygen atom is more electronegative. what does it mean by electronegative? So the oxygen atom is it has a tendency to attract electron ions rather than the hydrogen atom. So oxygen atom tends to be negatively charged while the hydrogen atom tends to be positively charged. So as you can see here, compound made of hydrocarbons and carboxyl groups which are made from glycerin. So these are the compounds we found in the PFAE oil. So as you can see, the moisture breaks the fatty acid chain and ionizes the acid and alcohol. Where does the acid and alcohol come from? These two components are coming from the aging product. So when the oil is added into the transformer, when there's a functioning of transformer by aging, we can get the formation of acid and alcohol. So these two parts will break down the unsaturated chemical bond of carbon, hydrocarbon, producing moisture, where you can see that OH and O in both these reactions. So it is a small finding I found out in the papers. So as you can see, this is a comparison between mineral oil and PFAE. When we add a certain amount of moisture, for example from 0 to 5 ml, so you can see the breakdown strength of the mineral oil and the purified fatty acid ester oil is decreasing. But then when you add a 4 to 5 ml of oil of moisture to PFAE, there's a certain increase of breakdown voltage strength. This is due to the absorption of moisture by the PFAE hydrocarbon molecules. So how to reduce or how to overcome this moisture in oil is that we can do by filtration or degassing. And then there is another part where we can do filtration by having purification system. So that's for my part. Next will be James.
Apart from the presence of gas bubble and moisture, solid particles also contribute to the reduction of the voltage strength. Many publications discuss about the presence of solid on the effect of voltage breakdown in mineral oil. But very less publication discuss on the effect on the vegetable oil. So, two papers were taken to discuss the presence of solid particles in vegetable oil. Two different tests. One is with the metallic, particularly copper particle, and another test is non-metallic test, which they use carbon particle and cellulose particle. These two tests use the same vegetable oil obtained from rapeseed oil through three processes. They are obtained by the refinement of alkaline, followed by the vacuum distillation, and lastly through the leaching process. As for the metallic test, the mineral oil was obtained from PetroChina Coal Ltd from Beijing, China. Whereas for the non-metallic test, the oil was obtained from China National Petroleum Corporation. Let's look at the properties of the insulating oil. This table tabulates all the properties of both vegetable oil as well as the mineral oil for metallic test and for non-metallic test. What I want to highlight here is in red. So the viscosity of the vegetable oil is 43. It is high as compared to both the mineral oil used in metallic particle test as well as the non-metallic particle test. So for the metallic particle test, we can see that the presence of the copper particle, particularly this line shows that the presence of copper leads to reduction of voltage breakdown strength. So as the size of the particle increases, we can see that the lower the breakdown voltage it is. So as compared to this is a mineral oil. We can see that for the same size, same particle size, we can see that the breakdown voltage in vegetable oil is about 52 52 kilowatt as compared to about 42 kilowatts as in the mineral oil. For the next test, for the non-metallic test, the presence of carbon particle or cellulose particle shows that the decrease in breakdown voltage as in vegetable oil is higher than the one in mineral oil. And what I can find in this test is the viscosity of the vegetable oil is higher, as shown just now in this table. It shows that the high viscosity in vegetable oil, it exhibit this kind of property, whereas the low viscosity level in mineral oil, it increases the movement of particle charge. So as the movement of particle charge increases, it produces bubble gas in between the electrode, and when all these gases they bridge together and breakdown will occur. So methods to remove the solid particles can be done in 3 ways through filtration. The first one can be done through the gravity filtration, where they use the gravity force. The second one is the pressure filtration. They use the difference in pressure before and after the filter. And lastly, the filtration through extrusion. They use a press to remove the solid particle from the insulating oil. By considering only the existence of solid particle in the oil, vegetable oil shows good property as compared to the one in mineral oil. So hence, the higher viscosity level in vegetable oil leads to slower rate of reduction in breakdown voltage as compared to the one in mineral oil.
Okay, so now I will discuss about different tests that can be used to determine the breakdown voltage of vegetable oil and also mineral oils. So the 3 tests that we will be considering is the impulse test, the AC test, and the DC test. So firstly, for the impulse test, this is the configuration that we use. We will use a shock generator, normally a Mux generator, to generate a very high voltage to be applied on the terminals and the insulating material in between. So for the lightning impulse test, we can see that this creeping discharge is observed. So here in figure A is observed for mineral oils and also vegetable oils at a negative polarity lightning impulse. And in figure B, we can see that for mineral oils and for vegetable oils, a lightning impulse at positive polarity. So we can see that at the negative polarity, we can see that the streamer distribution is shorter compared to the positive. We can also look at the negative, that it has a very high magnitude compared to the positive, where in negative it has a negative 128 kilovolts, but positive is only 78 kilovolts. So we can see here that the permittivity of the insulating oil affects the streamer propagation. So we know that mineral oils have a higher permittivity, about 3.2, compared to mineral oils which only have 2.2. So because of that, we can compare and see that the streamer propagation of mineral oil is shorter compared to vegetable oil. So we can conclude that in the lightning impulse test, mineral oils perform better than vegetable oils. The next test is the AC breakdown test. And the AC breakdown test, we will use an impulse generator or a transformer or a DC generator to generate a high voltage, a high AC voltage, which will be applied on the insulating material at these 2 terminals. So what test we are using is, we are using a creeping discharge test, and we will observe the pattern that is observed. So what happens is, we can see here there is mineral oils, there is refined vegetable oil, and there is unrefined vegetable oil. So we can see here, for the creeping distances, we notice that the mineral oil has longer distances compared to the vegetable oils for both refined and unrefined. Some papers, they have concluded that the distances of the creeping discharges is proportional to the velocity of the discharges. So the higher the velocity of the streamer propagation, we know that electric field is also higher. So we can see that at a fixed voltage, the effects of breakdown is much more seen in the mineral oils. So from the AC breakdown test, we can say that mineral oils, they perform worse compared to vegetables, because vegetables have a smaller distance, and so we see that the damage is less in vegetable oils. Finally, for DC breakdown test, we use the same configuration for AC breakdown test, and what happens is we apply positive polarity and negative polarity for mineral oils, refined vegetable oils, and unrefined vegetable oils. So what we can see here is that the distribution of the discharges is not radial. That is because there is an unbalanced electric field, which causes the one side to be more, the electric field to be stronger, so they are more concentrated on one side. What we can see here is that at 80 kilovolts, we can see that they are quite equal in the distances. But we can also see that for positive polarity, for vegetable oil, the discharges are radial. So this shows that vegetable oil actually evenly distributes the discharges, which perform better than mineral oils, which can focus on only one point. So we know that in the DC breakdown test, vegetable oil actually performs better than mineral oils. And this is because of the electric fields that are more balanced in the vegetable oil. Alright, so that is for the DC breakdown test. Now I'll pass the time to Lim, who will conclude. Oh, wait, before that, we can see from this graph that the final length of streamers for varying applied voltage for positive and negative. We can see that mineral oils are in red, vegetable oil in blue and green. We can see that mineral oils, at positive, they perform better than vegetable oils, but for negative, we can see that vegetable oils, they perform better than mineral oils, which have been stated is because of the radial distribution of streamers. Right? So that is all for me. I will pass the time to Lim.
Vegetable oils has the potential to become the alternative way to replace the transformer oils, but the vegetable oils still have many unsatisfactory points. That means the vegetable oils, they require some treatment before they can apply in the service, and this is the field that our engineers do the things to mitigate it to become a better insulating oil. Thank you.